All right, we're starting Unit 4.2. Despite the fact that your yellow notes say 4.1, which we'll fix tomorrow, this is Unit 4.2, okay? So this is your vocabulary, and you need to know what it is. And so we're going to be factoring and finding factors. And you have done this in the past. And when you did it in the past, you did a couple of different methods. You did factor trees. So like, let's say you had 36 and, I don't like 12. 36 and 16. Let's say we're trying to find the greatest common factor of 36 and 16. Okay, and so you guys might remember this. You did 4 times 9, and then 4 was 2 times 2, and those are prime. 9 is 3 times 3, and those are prime. So my factors are 2 times 2 times 3 times 3. Okay, you can still do that. There's nothing wrong with that. And then over here, 16 is 4 times 4, which is 2 times 2 times 2 times 2, which means 2 times 2 times 2 times 2 is 16. Okay? So we've kind of already started talking about smart factoring. So riddle me this. Did I really need to go any further past this? If I was trying to find the greatest factor they had in common, did I need to go past 4 times 9 and 4 times 4 to see that 4 is their greatest common factor? Because I know that 9 is 3 times 3, and I know that 4 can't be divided evenly by 3. Okay, so we want to kind of be smart, just like we did when we did the division. We want to, like, if I don't have to divide further, I don't want to divide further because I'm not trying to waste my time. Okay, this is the factoring that you did before. You were trying to find the factors, and then when you were trying to find the greatest common factor, you said, okay, well, we have 2 times 2, 2 times 2. That means the greatest common factor is 4. Okay? Now, what's different? Here's what's different. Letters. Okay? That's what's different about algebra. It's what's been different about algebra the whole time. So now we have letters, which you may be inclined to let freak you out. But remember, all letters means is that just like when we expanded the numbers and expanded the letters, that's all we're going to do. We're going to look at expanding them. So we're going to expand everything. That's our strategy. We're going to expand. It's almost exactly like the dividing polynomials we did. We expand and cancel, except we're not going to cancel. Right now, we're just trying to find out what they have in common. We're trying to find out what we could cancel. Okay? So let's look at this one. Let's pretend that, let's look at it. So I have negative 12 and 21. Now, this is just a plain old numbers, okay? But we threw in that negative, all right? Now, when you see a negative, I want you to make negative 1 one of the factors, okay? Negative 1, because just do it, okay? Because if you just put a negative out there, sometimes it gets weird and confusing, okay? So let's make, if you see a negative, let's make one of those factors negative 1, okay? Now, 12, if I look at this, I know that 12 is 3 times 4. Now, why didn't I do 3 times 2 times 2? Because I know that 21 can't be divided by 4. 21 is 3 times 7. So I already know that 4 is not going to be one of the common factors. They're not going to have that in common. The thing they have in common is 3. Okay? So what does this mean? This means their greatest common factor is not 1. This equal sign with the not line through it, that means not. So negative 12 and 21 have a greatest common factor that's not 1. All right? Now, we are going to want to know what that greatest common factor is, but it's important that we know that it has a greatest common factor that isn't 1 because that's going to matter when we start factoring. Okay? Let's try this next one. 21x. Well, we already know that 21 is 3 times 7. But now we have with this x. Well, all that means is it's also times x. Okay? 40y, okay, again, if I'm being smart, can I divide 40 by 3? No. Can I divide it by 7? No. Can I divide it by x? It doesn't even have an x. No. They have nothing in common, okay? I can factor this out. I could just go nuts and say this is 2 times 2 times 2 times 5 times y, but I don't need to do that to know that these don't have any factors in common. The only thing they have in common is 1. And so we would put these over here. A lot of people think that when they don't have anything in common, that they have no greatest common factor, but they do. The greatest common factor is 1. We need to know that. All right, let's try this one. Y'all take a second and try this one. I'm not going to make you, I'm going to pause and give you time to do it, but I'm not going to quiz you on it. I just want you to try it. Okay, for this one, okay, so I know that it's -1. It's got a -1. Okay, well, and so does this one. Okay, now, do 6 and 7 have anything in common? No, 7 is prime, so I know I can just put times 6 here, and I can put times 7 there, because I know I don't need to take 6 any further. All right, now, a squared, I'm going to go ahead and expand. And AB, I'm going to go ahead and expand. Because I'm going to use that, and again, so this is where we're going to keep on doing the same old expanding step that we did. All right. Now, what are they? I see on both of them. I see a -1 on both of them. I see an A on both of them. So the GCF for this one is -1A. And by the way, the GCF on this one is 1. Okay, and the GCF, sorry, I didn't write that here. GCF on this one is 3. Okay. And so where would this one go? Is it a GCF? Is it 1? Is it 1 or not 1? It's not 1, so I'm going to put it here. So I'm going to put -6A squared and -7AB. Okay. I've already spent a lot of time on this, so I'm going to save these for us to do in class tomorrow. All right. Now, let's look at this next part. So this is what we're going to have to actually do. So we're going to be finding our greatest common factor. So let's look. What do these both have in common? You can kind of almost tell by looking. And if we expand them, like we did before, 5 times n minus 5 times 7, they have a 5 in common. So my GCF is 5. Okay, let's expand this one. We have 3 times W times W plus 3 times 3 times 3 times W. Now you could have just put 3 times 9. Okay, well they have a 3 in common and they have a W in common. So my GCF is 3W. Okay, y'all try this one. Okay, so for this one, I have a 5 times P, don't start, plus P. What do they have in common? P. The GCF is P. Okay, we'll save these two to do tomorrow. Now this is, so this again, all we're doing, it's almost like we're doing the top part of division right here. Okay, so now let's look at this right here. This is what we need to do. This is where everything was leading us to. Okay, so if I have 5p squared plus p. So remember, when I expanded that, I had 5 times p plus p. All right? So what was the greatest common factor? It was p. So I'm going to rewrite that with p in the front, and I'm sorry that we used the letter P, and everything else inside. So what's left? Well, I have 5p plus, what's the invisible coefficient? 1. Okay, so you're like, what did she just do? Let me tell you what I just did. I undistributed p, okay? And that's what factoring is. It's undistributing. I know that sounds crazy. All right, let's jump up to this one really fast, and I want to show you with this one, okay? So for this one, I have -1 times 2 times 3 times q times q, all right? And then I also have minus, well, so I have -1, put a bar through that, times 2 times 2 times q. What do they have in common? Well, they have a -1, they have a 2, they have a q. So that makes the GCF of this one -2q when I multiply it all together. Okay? So let's take that one down here. So I'm going to do the same thing. That same exact step I did here where I expanded. So negative 1 times 2 times 3 times q. And, oh, there was another q. Sorry about that. And then I had, so it's okay. Negative 1 times 2 times 2 times q. I know, it's time. All right. Now, what do they have in common? Well, they have a negative 1, a 2, and a q. Negative 1, 2, and q. All right. So when I write this in factored form, I'm going to put the GCF is in the front, negative 2q. That's what I would distribute to put it back together. And then whatever's left goes inside. And if there's no minus sign, it's positive. Could I distribute this back out and see if it worked? I sure could. 2 times 3, negative 2 times 3 is negative 6. Q times q is q squared. Negative 2 times 2 is negative 4. And there's a q. When I multiply it back out, I got the exact same thing. So that's what we're doing with greatest common factor. We're going to practice this a bunch tomorrow. You know how to do factors. You've done greatest common factor before. We're just taking it to the next level. We're doing it algebra style.